This is Aaron with Eric Dollard again, and we're going to talk a little bit about the cosmic induction generator. That seems to have caused quite a bit of buzz as far as people donating money, wanting to see this. This is kind of a project that is more on the public side of EPD labs.
Right.
And so there's some pictures that have been released, you know, over the last couple of years showing these light bulbs with these real beautiful, like fractal type patterns and little, you know, swirling around in these bulbs.
Yeah.
And you want to explain a little bit about, kind of orient everybody to what that's all about?
Well, it goes back to a concept by Wilhelm Reich called cosmic superimposition, where you have the creational forces combined to produce archetypes of galaxies and living forms. And I had accidentally discovered this with a friend of mine in Bolinas when we were attempting to put a real Tesla transmitter system together. And it wasn't quite as refined as these coils are what we have now. It's just whatever RCA gave us to work with. We couldn't be picky, so they said, this is what you got, this is what you got. So they gave us transformers, coils, a TCS transmitter, which we'll see soon from my high school days, using an exciter. And then when one of my labs got destroyed, we managed to get a couple of chunks. We got a transmitter frame out of a airport HF radio transmitter, put out about 1,000 watts, and we assembled this whole thing. And we had to put in an arrangement where we could get enough electricity through the power lines in a rural residential area to even run this thing. When it got going, all the lights in the houses around the neighborhood would just flash on and off like stroboscopes. So, because the power was pulling off the transformer.
Right.
But we got it together, and then lo and behold, it did things that nobody had ever seen before. You had electric arcs jumping into counter space. So in other words, there was only one pole, and they had a golden ratio geometric proportioning. They also had a time memory. This stuff only exists pulsed, because there has to be a season aspect to it. It can't be continuous. It's got to be based on a growth and decay cycle. So you keep hitting it with these pulses, and these discharges would burst forth in an organic geometric golden ratio patterning. But what we found when photographing them and what have you is that even though they were a succession, there was a memory, and the first one remembered to turn one way and the other one knew to turn the other way, and there was this combinational sequence dance going on. There was some kind of time frame situation.
They were synchronized somehow.
Somehow they knew. So we started off with the disruptive discharge mode originally. So we had a dumpster in San Francisco, a place called Lease Light, and we used to get cases of the big incandescent bulbs, series street lighting system from on Van Ness Street in San Francisco. Had hundreds of these bulbs. And they pulled them out every so many hours, and we pulled. So we had boxes and boxes. It didn't matter, you know, they were expendable. The more burned out they were, the better they worked for what we were doing, because you couldn't have any metal in there.
Okay.
And then so we fired this thing up one afternoon. We built this in David's bedroom. He moved outside, and we converted his bedroom into what we called, I forgot why we called it K-Lab or something. We put, you know, built the RF benches and had ground rods all over the place. We had our own substation hanging on the wall with a big capacitor bank and everything, so we could get enough juice squeezed through the power line. So we fired this thing up, and we put the light bulbs in there and started working them, and lo and behold, the whole galaxy appeared in the light bulb. The little stars, the whole nebula, the whole form was just floating around in the light bulb, and
Right.
yeah, just like you would see on one of these, you know, PBS, you know, deep space programs. It was just absolutely stunning. David had hollered for his mother to come running in, and she came, you know, running through the door. At that point, the light bulb viciously exploded, and that was the end of that.
Right.
She didn't get to see it. But it wasn't long afterwards that the Farnsworth family showed up. And then...
so you're doing that before you ever met them?
No, I already knew them.
Oh, you knew them?
Yeah, Philo had his mother come from Utah to see what David and I had going on.
Okay.
Because it was like very closely related to stuff that his father was working on in the fusion.
Did you already know about the Farnsworth fuser at that point?
Yeah, Farnsworth and I had already, you know, had gone through our meeting interval and ritual, you know, in which he finally revealed the existence
One-upping
of these
each
things.
other?
Yeah, he revealed the existence, feeling totally confident that, that I would not be able to figure out how the tubes worked.
Uh-huh.
But I did. And that created quite a shock for him. So at any rate, then his mother came from Utah with a whole box of tubes for me to look at, and brought them there. And so we were demonstrating this stuff to the Farnsworth family. We managed to get the situation more stabilized in the light bulbs. The problem is there's an ether pressure in the bulbs, and it causes them to explode. And if you melt a hole in the bulb with the discharge, the vacuum is not impaired by the air rushing in, because the ether starts to shoot out of the hole in the bulb, and it keeps the right low pressure gas balance, and the discharge remains stable until you turn off the power, and then the air rushes in.
So even with a hole in it, the pressure is
The
constantly
ether
out.
pressure shoots out the hole. It's a little purple jet of like compressed air shoots out the hole, and as long as the power's on, and it's in there's not a long gap between the pulses, it will maintain itself. So Tesla describes that stuff in his lectures, and I'm the only person that's ever been able to duplicate that. So the next step was to move it onto the RCA installation itself and go full power. So I got a space in the Marconi building. I got set up with a new batch of equipment, and at that point everything fell apart because of the common wheel and RCA, basically near extinction, and everything got torn apart, and I got thrown out, and that was the end of that. But I did manage to build in the time I was there, I did manage to put together a 10,000 watt unit. I had in that building.
What was the original one in your friend's bedroom?
In David's room, that was a pair 813s. That was about maybe 1,500 watts, 2,000 watts big.
Okay, so you upscaled quite a bit.
Yeah, big.
Yeah.
Well, I had a substation in my laboratory,
Right.
500 kVA substation. So I think I had a 1,600 amp three-phase 240 bus. I had a big bank of oil capacitor. There's some surviving photographs of this that made it out on the energetic form of the Bolinas transmitter side installation. So it was stunning. The discharges that came off of this thing were stunning.
Is that what created those fractal patterns inside those light bulbs? Is that
Yeah,
what
well,
those
this was even more powerful. The light bulbs, would just simply explode in this thing. It made you have to turn the power down to do the light bulb stuff. Otherwise, the discharges. So at any rate, that all got screwed up, and then there was the years of eating out of garbage cans, and the whole 11 years of living on the street in San Francisco, until there was a captain there on the bay. Captain Hughes had me move on his Navy. He had a converted Navy ship, and I rebuilt it, and he started supporting my mathematical research, and that ended up getting me involved with the Integratron. So when I got involved with the Integratron, then Van Tassel had somebody assemble one of these stupid cardboard tube things for him. And so at any rate, what I did, because Lockwood didn't really know me that well then, I showed him, what could be done with this stuff that nobody was getting. So I threw away the cardboard tube and reconfigured the thing to work as the way a Tesla transformer should. Then through the donations of the people coming that, would come through, and the Integratron was open, certain hours every day, and the tours, and the whole thing. People started showing up with transmitters, and so we put together a single-ended unit on the floor of the office in Integratron with the pieces of the old Van Tassel coil and the stuff I got from LA and all that. And this time we used 4 813s. And all the photographs that are available now of the discharges and the light bulbs were produced by that type of apparatus.
Okay.
So at any rate, the Integratron was taken away from us, and the facilities were basically, the technological infrastructure was completely destroyed. They used the building as a party center or something now, but everything was destroyed. They tried to get the Tesla transformers and all that, but somebody from Santa Barbara had showed up, and they pulled Peter Lindemann and Michael Knotts came and got the equipment, and we moved it to Santa Barbara, and then we started making the actual induction generator with the paracoils. you know, in the larger shape, and the whole thing was all put together. Lockwood and I had worked on it for months at the Dome, making dielectric cables. There couldn't be any screws, nails, or anything. We had to make a duplicate coil form like the one Van Tassel had. We put the whole thing together, the sheet copper turns and everything, and then I built another 10 kW driver for it. This time I put a AM modulator on it. I cathode modulated the tubes, and then we took a music synthesizer and put it into that, and fired this thing up to 10 kW, and this arc, the length of my arm comes off of the thing, and then organ music or whatever, the synthesizer music is coming out of it in pure fidelity, and it's just roaring.
And that's the best fidelity
The fidelity
system
is
that you've ever
indescribable.
heard. Right.
Indescribable. And you can play all the keys. It's completely linear. There's no intermodulation products. It's not limited to one frequency. You can put any type of sound. You can talk into it. And with this particular type of modulator, when you withdraw the modulation, the tubes are cut off and the thing just goes dormant. So it's actually proportioned to the music. So then the Borderland money and all that stuff got embezzled. We lost the place in Santa Barbara. We took the stuff to the shipyard. We were too busy. David and I were way too busy being, you know, electrical workers, you know, and being the engineer and all that to ever work on this stuff. And then the shipyard started going through its downfalls. You know, the ship we spent 4 months building sunk in the first job. The idiots sunk it. They didn't put the equipment that I specified for the bilge pumping in, and they collided with another ship. And it sunk, so we quit, and all that equipment was scattered to the winds, and that's been the end of it ever since.
So what's, you can explain a little bit about what's going on next door? in this
So
room
what
that
we're
we'll-
doing right now is
We'll walk in there in a second.
we're rebuilding it. And then it also, the thing also splits in half and it does the telluric work.
Mhm.
So this crystal radio initiative, there's very little difference between that and the so-called cosmic induction generator. So the thing here in Nevada is an effort was made to find the equipment that was scattered from the shipyard. It ended up in Hollywood. Okay, I knew the guy that had it. I knew he ended up with it, but he is a manipulator or whatever. So basically the stuff was all embezzled and nobody can get it back from him.
Mhm.
So it's gone.
Okay. We're gonna walk in the next room and
Yeah.
we can kind of look at the equipment and stuff.
So I just spill over on the carpet. Snap.
Tell us about these real
So
quick.
these are the transmitters.
The monsters.
Yeah, they're actually small.
Yeah. So these were in an AM radio station?
Yeah, they came from, one came from Washington, the other one came, I think they both came from Washington.
Uh-huh.
Two different stations. So to find a pair is kind of amazing.
Right. And so
These things are kind of in demand, so.
what era did these come from?
Area?
Era, like time? What year would these
Oh,
have been?
probably 60s. They're nice pieces of equipment.
Uh-huh.
There are a few design flaws, but it's not really going to matter much in operation. The big complication is keeping the RF confined here so these things aren't heard. Experiments aren't being heard all over the world on the AM band.
Right.
As you see, we frown on that. So a big expense in putting the electrical system in here is, one, it's got to be powerful enough for this.
Mhm.
And two, it has to be designed in such a way that the power lines don't turn into antennas. So that requires a lot of expensive transformers and grounding networks and whatever. So one of the reasons this building was picked is it was originally opened as a Chevrolet dealership in the 20s. And there's 15,000 gallon and a 35,000 gallon gas tanks buried out there in the ground.
How many gallons?
35,000 and 15,000.
Wow.
So there's an electrode in the ground buried out there that's a good sized fraction of this whole building's volume. So that makes this location priceless.
Right.
So we'll ground all this to there, and there'll be no metallic connection between the electrical system in this building and this miserable power company cluster we got hanging out here, which is just going to act like a giant antenna. So that's what makes a lot of this stuff more difficult.
So with these powered up and upscaling the cosmic induction generator, these would be powering it
Yeah.
instead of these smaller.
Yeah, so these things, with 100% modulation, they put out 20,000 watts peak envelope power. This is what we got now. And they're all screwed up, so.
So this is John Polakowski here, working on a project with Eric Dollar
Yep. Hi.
here at the lab in the middle of the desert.
So where you got this figured out?
Yeah, all the continuity checks out.
Okay.
How they're soldered, I'm just cleaning them up. Do you still want the electrolytic?
Yeah, everything's got to go back to original.
What I mean is that one doesn't have an electrolytic. Do you want?
No, it's got to go. That's
Okay.
not original.
Okay.
This thing looks like it got mashed a little bit.
Eric, do you want to explain a little bit about the coils here? And these are coils that John had been working on the last day or two, putting the frames together. There's primary and secondary, and there's two sets.
Yeah, it's not a transformer in the normal sense in it. This is a resonator. And it has to be excited into a certain mode, like a waveguide. So the engineering of that has never been presented. So I had to figure that out myself.
So the radio transmitter is going to be
The
used
exciter.
as the exciter
Yeah.
for those.
So there's an exciter coil here. It's a smaller one. And then the transmitter connects to that. And then this is the monopolar output that normally goes into the earth. This end here just terminates. So all the plasma stuff and what have you goes on here where the dielectric field is, but there's no real transmission there. The transmission is out of the neutral terminal into the earth. So in order to make it so that doesn't become a problem is you have another coil wound in the opposite direction. So that one becomes symmetrical with this, and then the energy can't get out, it bounces between the two. And that makes it then a laboratory device for doing induction heating and plasma type work instead of a radio transmitter. Transmitter and receiving coils are one. That makes the connection to the transmitter a little more difficult because it's balanced. And then these are arranged with a complicated frame arrangement so that the coupling can be changed. In other words, the primary or exciter coil and the main resonating coil can be moved, and also the two can be pointed at each other because for the plasma work you want a concentrated field. You don't want something that fills up the whole room.
So with those two sets right here, would, for example, you put the bulb like directly in between them?
Yeah, between the two.
Okay.
Otherwise, you normally just put it where the
So-
field
so
around
you
these
go
is
right
just
there.
like what you see in a child's science book about a bar magnet. You know how the lines go around?
Okay.
But with this particular type of double monopolar field, there's some other things going on that maybe we can show later that are very puzzling. There's certain things in electrostatics that are not being understood, and this really gets into that. And with this device properly proportioned and tuned and powered, you can either do it in the CW mode with the vacuum tube equipment, or you can also do it in the disruptive discharge mode with the spark gaps or any of that type of stuff. It'll work either way, so they're pretty universal.
So as far as the construction of these coils, I mean, we don't, obviously can't do a whole how-to here, but basically everything is wood, there's no metal.
No metal,
There's these plastic tubes with grooves that John cut in these for the equidistant spacing.
Yeah.
So there's no metal, there's even, wooden pegs put in to attach the wood. And so that looks like thin copper tubing, or no,
Yeah,
that's
it's
actually
tubing.
wire. That's not, oh,
No,
it
it's
is?
tubing, yeah.
That is tubing,
Yeah,
okay.
because the high frequencies, the metal on the inside doesn't contribute.
Okay. And then
And that's what this is. This is a coaxial cable, and the outer shield is used as the conductor, so-called conductor.
Uh-huh,
The inside does nothing on this.
okay.
So what this does is this provides a very thin silver-plated copper tube,
Uh-huh.
and it's always, the Teflons are the silver and copper, and the Teflon, if you put Teflon on, you have to silver the copper, so if you get Teflon cable, you're guaranteed the silver. So now you have, not only you have a nice piece of silver tubing, but you have a Teflon sheath around it that helps minimize the corona, and the Teflon doesn't burn. So if you start getting flashovers or arcs start jumping off of things, you don't get any carbonization.
Right.
So even though the wire was designed for a completely different purpose, it has a unique, properties that make it good for this too, so they tend to be built out of that. The solid wire wouldn't contribute to anything at the frequencies involved.
So this whole radio transmitter receiver setup, this is Navy?
Yeah.
So this
World
is,
War II Navy, they was
so
mostly
this would
used
be out on
on,
a ship?
yeah, PT boats. The biggest ship that I seen use these was when I was rebuilding the LCS 102. They had a pair of these in their radio room. Because any vessel that was expendable, that likely was going to get destroyed and didn't come back, then these were popular on those. And then the manual also, they can be used in a vehicle, so they'll work, but it's kind of heavy. But that heaviness makes them, you can see this, you don't find equipment that's made like this anymore. This stuff is,
It's rugged.
it's just completely solid. There's no way that this stuff really
Right.
can screw up.
So this is the power supply,
Yeah.
which can be run off of a 12-volt battery
Right.
to the input.
Right.
And then, is this a motor turning?
That's what's called a
generator?
dynamotor.
Uh-huh.
So what it is, it's a motor and generator in the same winding configuration and fields and armatures. So it's a DC to DC transformer.
And so one output is 440 volts?
Yeah, one's 440 DC and one's 220 DC, and that's derived from the 12 volts DC.
So the 200 something?
220.
So the 220 goes to the receiver.
Yeah,
And this is the receiver right here.
yeah.
And then the 440 goes to the
The
transmitter.
transmitter, yeah.
And both of these are transmitters? And
Yeah,
And so between both of these, there's a couple problems, so you're
Yeah,
trying to
so,
build a complete
yeah.
unit that works.
well, initially they did work,
Uh-huh.
but then one of these, these things end up in the hands of ham radio people, and they get in there and start cutting wires, and, and so we're de-ham
Not
radioing
original,
this
right.
one and turning it back into the original. The tuning coil took a spot in this one.
Uh-huh.
So the only thing we could do is extract it and bypass it, because for what he's doing, he's just going to use this as the master oscillator.
Now, does the receiver get used in this at all?
Normally just confirm that your transmitter's on frequency and you're not splattering outside of your band. So
Okay.
it's like an
So you
FCC.
so you tune it to its own transmitter?
Yeah.
And then you can see that you're locked on.
You're on frequency, you're not interfering
Right.
with any other services, there's no harmonics, or
Right.
it's kind of an
So that-
FCC requirement that,
Yeah.
you have a frequency monitor and those
Uh-huh.
kind of things to,
Right.
when you're doing this stuff.
Okay, so it's just to keep you on track, but it has no functional purpose as far as the...
Well, later, because the receiver will connect to one coil, the transmitter will connect to another, and then we'll get separated in space.
Okay.
That's also one aspect of
Wow.
going on, and then whatever service you operate at, in this case, the amateur radio is the most convenient right now. I mean, it was at RCA, it was supposed to be on the shipboard frequency.
Uh-huh.
The system I was building there was on 500 kilocycles.
Right.
And then the final system was going to operate on 126 kilocycles. The station had a license for 426 and 126 kilocycles. And it had, my RCA book shows, how giant the ground system is and all that. The ground system there is massive, tied right into the San Andreas Fault. So everything was right to do it.
Right.
But the usual situations manifested themselves and nothing came out of it. Everything was trashed.
Now, if we're able to, be fortunate enough to have this come together and do a demo today, what would we be able expect to see with this setup?
Well, right now, we're just trying to find out what the resonant frequency is. That's the first step, to compare it to the calculations. You gotta find the frequency. It's gonna be off because the tuning rings aren't on and all that, but that's okay. The thing is to get them tuned up, ascertain their frequency, figure out what their drive impedance is, figure out what the magnification factor is, and then try to get the power level raised with another power supply here that puts out like 800 volts instead of the 440, because the tubes are good for that, about 750 volts. And get it up to the point where we can start, lighting up fluorescent lights, or maybe getting some kind of, at least discharges off of it.
So like 800 something into the same transmitter?
Yeah. Well, when I was a kid, this was my first transmitter. In the ham radio tradition, I beat the hell out of it. I had 1,000 volts on the plate. I lit a 200-watt light bulb off that radio, and it was rated for 40 watts, but it's built so damn good. And if you're careful, you won't burn it up. It'll operate.
So did you have one exactly like this, or similar, like this vintage
Well, they're all TCS, but you know, you got TCS 12, you got TCS 14. It's a Collins design. That-
Yeah, TCS 12.
Yeah, it's actually one of Collins' first radios. This is what put them on the map.
Uh-huh.
Was this? And then what the Navy does is then they contract it out. Collins comes up with the design. They build the first radios, and the Navy goes, you know, you could even get a contract with the Navy to build these if you could do it in your garage, because that's the way they operate. And so this one was built by, this is a Collins, okay? That's why it's too bad this one got screwed up. See how this one's like all nice, you know, and lacquered, and this one
Right.
looks like, you know, it got pulled up, you know, from the bottom.
So they got a contract to build the
Yeah,
same
so
thing
this
as
one's,
spec.
this one's Stuart Warner.
Okay, but Collins is the one to go with? That's the preferable?
Well, you know, this stuff is not on order anymore.
Yeah.
You know, it was a miracle, and it wasn't cheap.
Whatever you're lucky to
Yeah,
come
so over
across.
$1,000 was spent on this stuff.
But if this is all brand new on a shelf and you could walk up to it, Collins would be the,
Always the
Reference.
Collins, same thing with
Always.
the PRC 47 in my car, that's another Collins design.
okay.
And you always prefer the Collins equipment.
And that was
Well,
all-
mainly
that was- that
because,
was
you know,
on-
it's also, you know, it's a style thing too. You know, if you have the Collins logo and the Collins, that's what everybody wants.
Right,
You know, you want your station to be whatever you say you want it to
Right.
be. You don't want it to be some half thing. You want the real stuff.
right,
You know, like this radio even smells better.
right. It's got the right blend of chemicals.
Yeah, it's got the right blend of PCBs, or, well, actually, there's no PCBs in this, but that lacquer they put on, the fungicide, is a similar
Yeah.
formula, and it gives it that radio smell. You could, you know, synthesize it with just the right amount of transformer oil and solder flux, and it's like Navy ships are the same way, they all smell like Navy ships.
And you got this all as a set, the power supply,
Well, I got one
transmitter,
set,
receiver,
And
and cables?
Yeah, and it wasn't cheap either, it was like $600 or $800.
Uh-huh.
So we connected it all together and it lit up. The receiver makes noise, but it doesn't receive, so I gotta find out why it's not receiving, but it sounds alive. The speaker doesn't take audio from the receiver, but the receiver's putting it out. I gotta find out why that is. The transmitter tuned up, but then the coil broke. So now this one here, this one that John's working on was bought separately. And it came with no other things, but other than spare tubes and a connector to make a cable, which is, it's fine, that's all you need. You know, it's got its case, it's all intact. And that one was, this here, it's $400.
Uh-huh.
So you're looking at $1,200 right here
Right,
for basically junk. So it's not, that's the obstacle. You know, first you gotta find this stuff, and then it's not cheap anymore.
You might know me from the Energetic Forum. My username is jpolicow, and I'm here to tell you why you should help me build the cosmic induction generator. So what is the cosmic induction generator? Well, basically it's two Tesla coils that are mirror opposites of each other, pointed at each other to create an extreme dielectric potential in the middle, and a point in space right in the middle. And everybody's seen what happens with one Tesla coil. You have huge giant sparks coming off the top capacitance. Well, what we're trying to do here is not create any sparks, but have an extreme strong high voltage potential in the dead space in the middle between the two coils. Okay, so why am I building the cosmic induction generator? This piece of equipment right here. Well, about 4 years ago, I met Eric Dollard. He was homeless and looking for a place to stay, and I had an extra room available in my house, and I was part of the N6KPH group, and I saw that he needed some help, so I opened up my home to him and let him stay there whenever he wanted for as long as he wanted. And me and him ended up being great friends, and I helped him publish stuff on the Energetic Forum. I typed in posts for him and was able to respond to people from him, and in turn he helped tutor me in analog electrical engineering and also some non-conventional living aspects of electricity, the more organic nature, I guess you could say, of dielectricity and the geometries associated with it. So when I first met Eric, I was mostly interested in free energy. That's what everybody wants. Well, after talking to him for a while, that's one avenue I could have gone down, but I realized an even greater potential, and that was the cosmic induction generator, or the SIG. The SIG demonstrates some things that are supposedly impossible. One wire power transmission. Creating radiant matter. Transmitting DC through space, which is supposed to not be able to happen at all. Transmitting signals and power into the ground, into the earth. These are all things that Tesla coils can do that most people are not aware of. And so far, the project is coming along great. As you can see, I've got the coils built. I designed and built them myself. We have a 3-turn primary, and we have a 20-turn secondary, as specified by Tesla in his Colorado Springs notes. The Tesla is wound with RG180 silver coax, and we have our secondary capacitance rings here. And currently I'm driving it with a World War II era transmitter called a TCS. What needs to happen is to realize the full potential of this cosmic induction generator needs to be driven with a higher power driver, and that's what I'm building right now. I'm trying to give a demonstration at the upcoming energy conference, and to do that I need funds to help complete this.